Welcome back, grade 12s. Going to have a look at some more problems where we have got the independent events. A bag contains 15 marbles. What is the probability of selecting a marble and then getting a head on the toss of a coin? Okay, so what are the two things we're looking for here? We're looking at the probability of selecting a marble and then on a toss of a coin getting a head. So we've got to get probability of a marble and the probability of a head. Now, how many marbles do we have in the bag? It tells us that a bag contains 15 marbles. So to select a marble is going to be 1 over 15. We've already seen that with coin, when you want to get a head, it's going to be a half. So our probability of getting both a marble and a head is going to be 1 over 30. An easy one to multiply. Multiply the numerators and multiply the denominators. Now, let's have a look at another example. Determine the probability of choosing a 7 from a deck of cards, replacing it, and then choosing a king as the second card. Okay, so what are we going to do? We want to get the probability of a 7, and then we're going to get a king. So, probability of getting a 7. We've got a full deck of cards. How many cards is that? 52. So, our probability of getting a 7 is going to be 4 out of 52 because in the pack we have got 4 7s. Right, so now we take the 7, we put it back into the pack, and we're now going to select, try and find a king. Okay, again, full set of cards, 52. There are 4 kings, so it's going to be multiplied by a 4 over 52 as well. Okay, this fraction is not easy to do in our head, so we're going to do it on the calculator. So we're going to go 4, 52, and we're going to multiply it by the same fraction. Okay, and our answer is going to be 1 over 169. So that has simplified very nicely. Okay, let's have a look at another example. This time we're saying a single fair die is rolled twice. Find the probability of rolling a 1 on the first roll and then rolling a 4 on the second roll. So the probability of, in the first one we want to get a 1, and then on the second roll we want to get a 4. Again, they're independent. Getting a 4 does not depend on your 1 in the first instance. So how many numbers do we have on our die? We've got 6. So this one is going to be 1 over 6, and the probability of getting a 4 on your second is also 1 over 6. And that gives us 1 over 36. Remember, you can leave it as a fraction. You don't have to change it into a decimal or a percentage. Let's have a look at another example. In your cupboard, you have a drawer that contains 2 pairs of black socks and 1 pair of socks of each of the following colors: blue, red, and white. Each pair is folded together in matching pairs. You reach into the sock drawer and choose a pair without looking. And what happens? The first pair you pull out is a red one, and that's the wrong color. You're going to replace the pair of socks and you're going to choose another pair. The question now is, what is the probability that you will choose the red pair and then the black pair? So we want to do 2 things here. Probability, we want to first choose a red pair. Okay, so let's have a look at that. How many socks do we have in total in the drawer? We've got 2 black, a blue, a red, and a white. So that gives us a total of 5. So the probability of choosing a red, we've only got 1 red in the drawer, is going to be 1 over 5. Whereas the probability of selecting a black pair, how many blacks do we have in the pack? 2. 2 in the drawer. So it's going to be 2 out of 5. So the probability of drawing a red on the first, and there's our word again, a black on our second one, is going to be 1/5 multiplied by 2/5, and that gives us a final answer of 2 over 25. A school survey found out that 9 out of 10 learners like pizza. If 3 learners are chosen at random with replacement, what is the probability that all 3 learners like pizza? Now, I know it sounds quite strange because it says there with replacement. We've done quite a few of those already, but just sort of saying we'll put it back. It's going to make a difference if you leave it out. So what happens is here, you choose at 10 learners. What's the probability? Okay, they say that 9 out of 10 learners like pizza. So the first chance is 9 out of 10, the second is 9 out of 10, and the third it's also 9 out of 10. Okay, so the probability of 3 learners chosen at random, probability of them all liking pizza. Okay, so that's going to be our event. The first choice is 9 out of 10. The second choice is 9 out of 10, and our third choice is also 9 out of 10. Okay, so if we're going to do that one, well, you should all know what 10 times 10 times 10 is. It's 1,000. So all I need to do on the calculator is do my 9 cubed, which is on the calculator, gives me 729. So that's going to be the chance of those learners liking pizza. Now, the next example is also about pizza, but this time what happens, a national survey found that 73% of people in South Africa like pizza. Now, if 3 people are selected at random, what is the probability that all 3 like pizza? So now what happens, because there's so many people in the population, we assume that even if the person isn't replaced, it's not going to change the probability. So again, for this one, each choice is going to be 73%. So if we look at this example over here, it's our last one for this section, it's going to be the probability of liking pizza. Okay, it's going to be 73% times 73% times 73%. And of course, when we put that on in our calculator, it's going to be as 0.73. And we're going to cube that answer, and that gives us 0.389017. 0.389017. Remember, our instruction is normally to do correct at 2 decimal places, which means this has become 0.39. Okay. In the next segment, we're going to have a look at mutually exclusive events.